Fifth grade into math lesson 10.1. Interpret a fraction as division. I can interpret fractions as representing division of whole numbers. Spark your learning. An elementary school receives 5 boxes of minerals for its earth science classes. The 6 science teachers at the school share the boxes equally for their classes. What fraction of a box will each teacher receive? Okay, so once again, we have one whole, right? Okay, so we have our one whole. Okay, so all 6 of the boxes or 5 of the boxes are represented as that one whole, right? Okay, then how many teachers are there? 6. So we need to take that one whole and divide it into 6 pieces. Okay, now we said how many boxes were there? 5, right? Okay, so that was our whole. So we're going to take 5 times 1/6 because each teacher receives 1/6, or each unit was broken into 1/6, right? Okay, so this becomes 5 over 1 times 1/6, which becomes what? 5/6. So each teacher is going to receive 5/6 of a box. Ready? Build understanding. 5 students in the science club prepare 4 circuit boards for a small satellite called a CubeSat. If they share the work equally, how many circuit boards does each student prepare? Okay, so we have how many circuit boards? 4. Okay, so we're going to draw 4 boxes. And how many students are there? 5. So we're going to break each box into bits. Okay, so how does your drawing represent the situation? So basically, what does it represent? Okay, so what does the expression 4, and then we just said each box represents the 4 circuit boards, and each is broken into 5 sections for each student. So what does the expression 4 divided by 5 model? So basically that 4 circuit boards divided among 5 students. So write a division equation to model the situation. So 4 divided by 5 can also be written as 4 over 5, right? So what does your quotient represent? So each student will get to do what? Each student will complete 4/5 of a circuit board. Two scientists develop a new substance in a laboratory. They make a total of 5 milliliters. If the substance is shared equally, how many milliliters does each scientist get? Okay, so we'll draw a representation here in a second. So letter B, how does your visual model represent the dividend, the divisor, and the quotient of the division equation that the models the situation? We'll come back to that too. What is the size of each group, and what does it mean for the situation? Okay, what division expression models this? We have the 5 milliliters and we have the 2 scientists. So what is our group? What's our big thing that needs to be broken apart? The 5 milliliters divided by what? The 2 scientists. So we have 5 divided by 2, right? Okay, So then we would have 5 divided by 2 equals, and we said you put 5 in the numerator and 2 in the denominator because the divisor or the dividend goes in the numerator, the divisor goes in the denominator, right? So what is 5 halves? Equals 2.5. So to maybe represent that, so scientist one, and then here in scientist 2, so they would have 2.5 each, right? Okay, so how does your visual model represent the dividend and the divisor? Okay, so basically the dividend we said is what? The whole, so it was 5, right? So we have 5 whole circles. And then, and 2 scientists. What is the size of each group and what does it mean for the situation? So we had 2.5, right? Per scientist. Okay, because we could easily divide up to 4, right? And do 2 and 2, but then we had 1 extra circle, right? And then so we had to take that circle and do what? Split it in half and give 1/2 to one scientist and 1/2 to the other scientist, correct? Okay. Check understanding. Represent a situation with an equation or model or visual model and solve. 3 runners in a relay race share the 8-mile distance equally. How many miles does each runner travel? So there's 3 runners. Total distance is 8 miles. And then how many miles does each runner do? So what is in the dividend? The total, right? So what is our total? 8, right? Divided by, in our divisor, how many places did they share that mile? 3, because there's 3 runners, right? Okay, so this becomes 8 over 3, right? And what is 8 thirds simplified? 2 and 2 thirds. Because 3 goes into 8 twice. 2 times 3 is 6. 8 minus 6 is 2. And then we keep our same denominator of 3. So 2 and 2 thirds miles. On your own, model with mathematics. Model the situation with the division equation and find the quotient. 5 friends share 6 small bags of popcorn. If they share the popcorn equally, how many bags of popcorn does each friend receive? So we're going to circle 5 friends, 6 small bags, and then how many bags of popcorn does each friend receive? So what is our total? What's being divided up? The 6 bags of popcorn, right? So we have 6 divided by how many friends? 5, which equals 6 divided by 5. Because remember, a fraction bar also means division, right? Okay, so what is that simplified?
That is 1 and 1/5.
So 1 and 1/5 bags of popcorn. "12 friends shovel snow from 8 identical driveways. If they share the work evenly, what part of the driveway does each friend shovel?" So we need to do the 12 friends, 8 identical driveways. What part of the driveway does each friend shovel? Okay, so what is our total that's being broken that we need to break up? The 12 driveways. Oh, not 12 driveways.
Wait, 12.
8 driveways. We need to break up the 8 driveways and we need to divide it among 12 friends. So that's also written as 8 divided by 12. It's in fraction form. Okay, so what is that simplified? What goes into both 8 and 12? 4, right? 8 goes in, or 4 goes into 8 twice. 4 goes into 12 3 times, so 2/3 of the driveway. Now, does the first number in our word problem always be the first number in our equation? No. You need to first decide what is the whole and then how many parts is being broken into, right? Open-ended. Describe a situation that can be modeled by 3/5 divided by 5. Then draw a visual model to represent the situation and use it to find the quotient. So could we say there were 3 hot dogs and they need to be divided amongst 5 friends? Okay, so 3 hot dogs, 5 friends. So technically we could write out a word problem and say we had 3 hot dogs and there were 5 friends that needed to share them equally. How many did each one get, right? Or how much did each one get? Okay, so this would be what's our total? The 3, right? So 3 divided by 5 equals what? 3/5. So we would have 3 wholes, right? And we need to divide each of those into what? Into fifths, right? Okay. And then so basically that would be what? 3/15, which equals 1/5. So each friend so we color it in like that, right? Okay. So each person gets how much?
1/5.
Well, 3/5, right? So 3/5. Oh, I saw that. Okay. All right, number 5. An audio engineer divides 9 feet of cable into 2 equal sections to connect a pair of speakers. How long is each section of the cable? So 9 feet of cable, 2 equal sections. How long? So what's our whole piece? 9. And then divided by how many pieces? 2. So that equals 9/2, which equals what?
That equals
4 1/2, because 2 goes into 9 4 times, and then 4 times 2 is 8, and 9 minus 8 is 1. So we get 1/2 feet, right? Well, my thing isn't writing, so if you just want to write 4 1/2 feet, right? Okay, number 6. 2 groups of people sit at different tables in a restaurant. Okay, so after reading that, we decided that we would take 3 divided by 6 for the first group, which would get half a pizza per person. And then for the second group, we took 4 divided by 8, which got us 4/8, which then got us 1/2 a pizza per person. So we found out that even though there was a different amount of pizzas and a different amount of people, that each group would still get the same amount, right? Okay.